So today we're going to combine what we learned with and practice reviewed with circumference and area, and also with central angles and degree measurement. And we're going to actually, arc length is the length of an arc, and it is part of the circumference of a circle. So if I have this angle, and let's just call it angle X, if I want to find the arc length, okay, it's different from the measure. Okay, the measure is the degrees, the arc length is the length in linear measurements, inches, feet, centimeters, whatever. Okay, so to find the length of this arc, it's part of that circumference, so we're going to use the circumference formulas and then part of the arc. Okay, so that here, if I want to find the length of arc AB, okay, I'm going to take the measure of that arc, which we know is X degrees, going to divide it by the whole part of the circle, and then multiply by one of the circumference formulas. So if I want to find the length of this darkened arc, which is this arc right here, the measurement of that arc is 120 degrees. So our length is going to be equal to 120 degrees over 360 times 2 pi r. So 2 times pi times the radius. Simplify as much as you can. 120 over 360 reduces to 1/3 times 18 pi. Okay. And then 18 divided by 3 is 6 pi. Okay. So the length in terms of pi is 6 pi inches. Since we wanted this in terms of pi, that's our final. So I have planted a circular garden adjacent to one of the corners of my garage. And we want to fence in the garden. And we want to know how much fencing we need. So we're going to need this much fencing. Okay. This makes this a right angle or 90 degrees. So what we're concerned about is not the 90 degrees, but the fence, which is going to be 360 minus 90, which is 270 degrees. Okay, so the measure of that arc is 270. The length is going to be 270 over 360 times 2 times pi times 12. Okay. So if I reduce 270 over 360, it's going to give me 3/4 times 24 pi. Okay. 24 divided by 4 is 6. So that I'm going to get 18 pi. Now this is a real world example, so we're going to want to change that 18 pi to a decimal equivalency so that our length is approximately 56.54866, and I've said to truncate or go to round to 3 decimal places, so this will bump it up. So 56 and 549 thousandths. Now, a sector is a region bounded by the arc of a circle and the two radii in the arc center. So basically, it is the part of your circle that is surrounded by the angles, okay, and the arc. So it's bounded by the angle and the arc, kind of like a piece of pizza or a piece of pie. And again, the whole concept is the same. The length of that arc is going to be the measure of the arc divided by 360, so the part of the circle, times pi r squared. So that's the official formula for that. Okay. So let's find the area of the following sectors. So we know that the central angle here is 45. That means the arc is 45. Okay. And then we know that the length is 3 of the radius. Okay. So the radius is 3. The part of the circle that we're dealing with is 45 over 360 times pi r squared. So 45 over 360 reduces to 1/8. 3 squared is 9. So this is going to be 9/8 pi. And we can leave it in terms of pi, or using the pi button in your calculator, you could change it and get the approximate value. In the second example, we have a diameter of 12, but we need the radius, so we're going to divide that by 2 and get 6. If this arc here is 120, we know that the semicircle is 180, so that is going to leave us with 60 degrees for this part of the circle. Okay, so that's what we're concerned about. So we have the 60 over 360 times pi times 6 squared. 60 over 360 reduces to 1/6 times 6 squared is 36, and then pi, and 1/6 times 6 is 6. So its area is 6 pi. Okay, so today you learned that to find the length of an arc, we're going to look at the part of the circle that it intercepts, find that portion, and multiply by the formula for circumference, because arc length is just part of the circumference. Okay. Remember that arc length is an actual measurement, like inches, feet, centimeters, anything like that, okay, where the measure of the arc is the degrees. The area is the same process. We're looking at that part of the circle and then multiplying it by the formula for the area. Have a math-tastic day.